Hello everyone. Today I'm going to talk about solving data discovery challenge with Amundsen, an open source metadata platform. So my name is Tao. So a bit of intro about myself. I'm an engineer at Lyft Data Platform and Tools team. I'm a Airflow PMC member and a committee member. At Lyft, I'm working on different data products, including Airflow, Amundsen, and led the data or cost attribution effort. Previously, I working at LinkedIn and Oracle. So here is today's agenda. I will first talk about what is data discovery. Then I move on to talk about challenge in data discovery. Then I will start introducing Amundsen architecture, a bit of deep dive. And lastly, I will talk about the impact of Amundsen and a few future work. So what is data discovery? So in order to answer that, let's first talk about data-driven decision. I hope everyone agree all the good decisions are based in data. So in this case, who needs data? To answer that, every persona needs data. For example, like analysis, data scientist, from product manager to general manager to engineer to experimenter, whoever needs to make good decisions, they need to be made based on the data. Take a few more examples. For example, HR wants to ensure like the candidate's salary are competitive in the market. Like politicians, when they need to optimize their campaign strategy based on data. So the typical data-driven decision flow is like, first, assuming the data is collected. Once the data is collected, analysis will try to locate and find the right data. Once they find the right data, they will try to understand a bit of deep dive, the context of all the data they find. After they understand the data, the analysis will start creating report, like all the dashboards, research study. Once they feel comfortable, they will share the result. So, but this is not a single way. If the result is not good and found out that the data is not correct or not using the right data or not enough data, they may need to go back to step 2 to redo the whole process again until the result is satisfied by the stakeholder and move on. Like someone will make a decision based on that. In this case, the step 2 and 3 are mostly the data discovery portions. So let's talk about the challenge in data discovery. So let's use a case study to answer that. For example, let's say we want to predict the meetup attendance before pandemics. Why is that? Because even though we know a large number of people RSVP, but sometimes some of the RSVP people will not no show. We want to procure pizzas, drink, and chairs to make sure it's not over provision or under provisions. So how are we going to do that? We will use the data from past meetup to build a predictive model. For example, once we know the goal, we are going to locate and find the data. We are going to ask a friend or expert if they know any past study has been done, or ask the question in a Slack channel. Lastly, if any of this doesn't work, we will search in all the GitHub repos or other documents to locate any past study has been done. So now we find a table named call meetup events with a few following columns: attending, not attending, date, and initial date. Now the question is like, what does this columns mean? For example, does this attending column mean they actually show up or just RSVP? And what is the difference between date and initial date? Lastly, once I understand the context and semantic of these tables, is this data trustworthy and reliable to be used? So in order to do that, the approach will say, I'm going to ask the table or data owner. Then how do I find the owner? I'm going to look for for example, documentations, who is the last people to commit any change to this table in the GitHub, any conference page document. And then lastly, I also want to understand a bit more of the data shape and run a query like select star from this table, limit 100, to know the data shape. So you could see the whole process is not super productive. Based on research study, scientists spend like more than 30% of time on data discovery. And so data discovery itself actually is providing little to no intrinsic value. So in order to make a data-driven decision, the most impactful work happens on analysis. So we want to shorten the time spent on data discovery. So how to do that? The answer will be leveraging the metadata. So let me give a bit of intros of Amundsen. So what is Amundsen? In a nutshell, Amundsen is a data discovery and metadata platform for improving the productivity of different persona when interacting with data. Currently, the project is hosted at Linux Foundation AI, aka LFAI, as its incubation project with an open governance and an RFC process. So take a step back. Before Amundsen exists, how is Lyft data discovery looks like? You could see like from the left-hand side, we used to only have a few static Confluent pages, document all the core tables, and a few static metadata like descriptions, owners, ETL, SLA, etc. So the metadata is refreshed through a cron job, no human curations, and the metadata is not easy to extend. So now let's go to see what is Amundsen look like. Here is the homepage of Amundsen. It has a generic search bar to search any data sets indexed in Amundsen. Then you could see all the popular tags, group different data sets around the tags. Then you could see the bookmarks, like which table have been using frequently, and also the popular table, what table used most frequently within the whole company. Let's dive into the search bar. So for example, if I want to type certain term, like tables, behind the scene, Amundsen will kind of search based on both popularity and relevancy to search all the most relevant table. So once you select the dataset or table page, you go to a dataset page. You could see like the schema name, table names, descriptions, like day range, tags, last updated timestamp, all the frequent user, owners, and a lot of unstructured metadata underneath as well. On the right-hand side, you could see all the columns that belong to this dataset, like column name, descriptions. Once you click any of the columns, it could expand with a markdown syntax to surface like the column description as well as the column statistic. For example, a distinct value, min, max, etc., based on the type. You could also link and surface all the dashboard that has been used this table. For example, dashboard is like a research study. Like if the table has been used by many dashboards, usually it's a trustworthy table. You could also search like dashboard. For example, in the search bar, you could search an Amundsen, and then you return any dashboard has this Amundsen term as index. Once you click and find the dashboard page, and you could see a few metadata related to dashboard page. For example, descriptions, owners, tags, when is last run it, when is successful last run time. And you could see the view count of this dashboard, so as a dashboard preview page. On the right-hand side, you could see what other table has been used by this dashboard page, what are the chart name, what are the query names. You could also search like the user. So for example, if I'm a new hire, I want to know like the veterans in the team, what table they have been using the most. So I will go to search and see. for example, checking their page and see what table they own, what dashboard they own, what dashboard they bookmark, etc. So now let's go to the Amundsen architectures. So Amundsen architecture is a microservice architecture. It has 3 services: front-end services, metadata services, and search services. Metadata services serving the metadata requests from both front-end services as well as other microservices. And the store or metadata is pluggable. It supports multiple types. And the ingestion of metadata is through a data builder framework we built called Data Builder, which could connect to different heterogeneous metadata source and persist the metadata into Amundsen. So front-end services. So front-end is written in a modern data front-end stack like TypeScript, React.js, and state management with Redux. So let's talk a bit about metadata services. It's a proxy layer to interact with different graph database with the API. Currently, it supports different graph databases like Neo4j, which is Cypher language based, AWS Neptune, which is Gremlin based. We also support Apache Atlas, which is another popular metadata framework as meta store. We also support REST API for other services. We're pushing and pulling metadata directly. At Lyft, service communication like between different microservices are authorized through Envoy RBAC. Let's move on to search service. It's also a proxy layer to interact with search backends. It supports Elasticsearch and Atlas out of the box. It supports different search paradigms like fuzzy search, like search based on popularity and relevancy, and multi-faceted search, which is people want to search more pinpoint search. So let's talk a bit about the Data Builder framework. Data Builder framework is a generic ingestion framework we built, which is highly inspired by Apache Goblin. So it includes a few stages: extractor, transformer, loader, and publisher. Extractor connect to different heterogeneous data source and fetch records one at a time and pass it to the transformer stage. Transformer will do any transformation, for example, changing description, adding more text, and then pass it along to loader. Loader will loading the data into a staging area. Once it load all the data persists into a staging area, you will pass it along to the publisher to publish it to the downstream sink like Neo4j. So metadata could be very heterogeneous. For example, at Lyft, we support many different metadata sources like Redshift, Hive, Druid, Postgres, Presto. Even dashboard, we have 3 types like Apache Superset, More Analytics, and Tableau. So in order to support that, that's why we built Data Builder. Here is an example of how Data Builder works. For example, a typical scenario would be I want to fetch metadata from Hive and persist to Neo4j. We will go to using like Hive table metadata extractor, which is a subclass of SQL alchemy extractor. Once we fetch the record and pass it along to no-op transformer because we don't want to do any transformation, and then pass it along to file system Neo4j loader, loading to a staging area. After loading finish, you will pass it along to a publisher to publish to Neo4j. So how is Data Builder is orchestrated? Amundsen leverage like workflow engines, for example, like Apache Airflow, which is a very distributed parallel workflow execution, which also allows specified dependency to orchestrate the Data Builder job. For example, you could see the graph underneath is like many different metadata executing in parallel. In the meantime, they also have certain sequence. For example, all the metadata don't want to start execute before the table metadata is started. So currently, Amundsen support a rich building connector. Thanks to our community, they all whenever they build something, they contribute back to our Amundsen open source repo. If you have anything that is not included and have built your own, please contribute back to us. So let's do a bit of deep dive of different architectures within Amundsen. First, metadata model. So metadata, how we model metadata is very important. To start answering that question, first, let's say what kind of information or what metadata we consider as metadata. So a term from ground paper named ABC of metadata could help answer the question. A stands for application context, meaning like all the metadata needed by humans application to operate that we want to store. For example, where is the data? What are the semantic or context of the data? Then B is stand for behavior. How is this data created and used over time? Like for example, who is using the data? Who has created the data? C stand for change. How is the change in data over time? How is the data evolving? And what the code has been changing to generate the data? So after we talk about like what metadata, so now let's talk a bit more what data we want to index. The short answer is any data in your organization. Then the long answer will be, for example, data, anything from data store to people to dashboard to ETL process to notebook to even streams. We all want to index. At this point, Amundsen support like data store, data set, people, and dashboard, and we're moving to support more entity in the futures. So take data set as an example. So Amundsen has three main class seasons entities so far: table, user, dashboard. Table is a central node in dataset model. It extend and connect to other extended metadata like say column names, column statistic, description, watermark, so on and so forth. As of today, the dataset metadata include both manual curated as well as programmatic curated. It supports many different generic metadata like description, partition range, tags, GitHub source definition, which ETL tasks have been produced. Also, it supports unstructured metadata. For example, not every company share the same set of metadata. So we allow people to inject any arbitrary unstructured metadata into the surface in Amundsen as well. So, but one of the main challenges, like even within the same organizations, not every data set define the same set of metadata or follow the same practice. For example, some metadata only available in some data set, like tier, SLA, and as operate like something like those operation metadata. Next, user model. We believe user has the most context and tribal knowledge around data as assets. That's why we want to index user and connect user with the entity to surface those tribal knowledge. Next, dashboard. Dashboard represent the existing user research study. The model extend and connect, let's say, dashboard has dashboard group, query, metrics, chart, and you also connect with user and then connect back to the tables. Currently, dashboard metadata include description, owners, timestamps, which table using dashboard, preview, text, etc. The main challenge is like, although we model dashboard very generic, but we take more analytics as a MVP, so and model that. So not every dashboard metadata is applicable for other dashboard type. For example, Redash doesn't have a dashboard group concept. Next, let's talk a bit about push versus pull. So there are two typical approach to ingest metadata. One is pull model, one is push model. Pull model means periodically update the graph database by pulling the system through ingestions. It's preferred if this is waiting for indexing is okay, or it is easy to bootstrap to build up the central metadata for your company. Push model means like if the upstream source or client side pushing the metadata directly to a messaging queue, where the downstream services will subscribe, persist the information into a graph. This is preferred if you require near real-time indexing metadata, as well as if you have a clear interface to define the metadata. So currently in Amundsen, if you are using Neo4j and AWS Neptune as backend, is leveraging a pull model approach, but you could easily extend to be a push and pull hybrid model. Take the graph as example. The external service we could build an SDK with a defined schema, and the external services could push the metadata, leverage SDK to push metadata Kafka, and then we could use data builders to subscribe the relevant Kafka topic and persist the information into the graph. So if you are using Apache Atlas as the metadata backend for Amundsen, then it will be a push model. So Apache Atlas leverage different hook from external source to get the metadata during the query context. The downside of this approach is that Atlas doesn't support external source. For example, Redshift, if it doesn't have the support the hook interface. Let's talk a bit about why we choose Graph database. Why choose Graph database? Because data entity with relation could be very easy to represent and model as a graph. And all the performance is much better than RDBMS once the numbers of nodes and relationship in the graph are in a large scale. So also adding a new kind of structured metadata in the graph is super easy. You're just adding a different new node type with a connection, and then boom, it's there. So let's talk a bit about the search trade-off. Search result. So it ranks on both relevancy and popularity. So what is relevance? Take search Apple for Google, for example. If you get a result as orange, it means low relevancy for search. If you get an actual Apple, it means a high relevance. Popularity. So take the same example. If you get an actual Apple, it is kind of low popularity. But if you get an Apple company logo or result, it's a high popularity means because like Apple company is pretty popular, right? So we try to strike the balance to include both consideration. Like we take like name, descriptions, all the related field to consideration when doing the search. In the meantime, we also take popularity into consideration. Like we take the query activity and to weight the result. Next, let's talk a bit about the metadata source of truth. So what it means. So metadata is often pretty fragmented, and Amundsen is built to centralize all this fragmented data, metadata. It supports both manual curated and programmatic curated. If the metadata is both manual curated and programmatic curated, we treat Amundsen graph as a source of truth. But if the metadata is only programmatic curated and always updated in the upstream source, we disable the manual curated and treat the upstream source as a source of truth. Take the graph as example. If there's a description available in GitHub source, when the table is first created, it will available in high meta store and persist in the Neo4j. After that, if human is using Amundsen to modify description, we won't persist back to Hive and GitHub. And then we only treat the Amundsen graph as a source of truth. So other features. So first, announcement page. We build a plugin client to support new feature announcement or new dataset announcement. Next, central data quality issue portal. So we build a client to integrate with Jira and to allow user to report any data issue. User could also see all the past issue, data quality issue as well for the given data set. User could even request further context or description from the owner through the portal. Data preview. So it supports data preview as well. Have a plugin client with different BI viz tool. Data exploration. You could also support integration with other BI tool for doing complex data explorations. Let's talk about impact. So Amundsen is pretty popular at Lyft. We have 750 weekly active user, 150K tables, 4,000 employee page, and 10,000 dashboard. So in Amundsen open source, we have more than 950 plus in the community channel, 150 plus company in the community, and more than 25 plus company are using it in production. Here is a landscape of the community. So Amundsen is pretty extendable. A different company using differently. For example, Amundsen using to integrate with their data quality services as well as Databricks Delta platform. ING is using data on Amundsen with Atlas for data discovery. Workday is building a whole analytics platform named Goku, and Amundsen is a landing page for Goku. Square is using Amundsen to solve the compliance regular use case, and they contribute a lot. And here are the recent contribution from the community, like dashboard integrated for Asana, Tableau dashboard integrated for Gusto, and Looker from Brex, and Delta Analytics from Amundsen. So here a bit we'll talk about the futures. So we'll focus on main focus on Q4 will be data lineage. So RFC will be coming to cover how we surface lineage using different mechanisms, push-based SQL parsing mechanism. ML machine learning features entity. We were going to treat ML features another first-class season entity, like service features that feature upstream data set lineage, service various metadata around ML features. Metadata platform. So Surface like support other service metadata programmatic access using GraphQL API. Also, for example, a few use cases expose metadata to BI tool, integrate data quality service that helps score. Also support hybrid metadata ingestion, like we mentioned before. So thank you. Questions?